Hello everyone, this is Hading Tian. Welcome back to watch the video. We are learning chapter 6.3, Trigonometric Equations, part 2. In this section, we discuss trigonometric equations that involve functions of half angles and multiple angles. In 6.2, we have learned if we need to solve, for example, we have cosine x, for example, 2, cosine x equals 1, and then isolate the cosine x equals 1/2, and solve for the x. Now we do not have the x, we have 2x, we have 2x, and solve for the 2x, solve the x from the 2x, and maybe we have x over 3, and we need to solve the x from these equations. All right, let's see the first example. Before that, we need to be careful that if I have a cosine 2 theta divided by 2, this one is not equal to cosine theta. This 2 and this 2, you cannot do the cancellation. If you have a 2, for example, 2 times cosine theta over 2, this 2 can be canceled because here is multiplication. And if there is a 2 inside of the cosine function, the 2 cannot be canceled. All right, let's move on to see the first example. If I have the cosine 4x equals 1/2, how to solve for the x? How many solutions in the interval from 0 to 2 pi? What is the graph of cosine 4x? I know that for the cosine x, from peak to peak, this is one full cycle. This is 0, this is 2 pi. Here is 2 pi. And if I have the cosine 4x, so inside of the input area, we have the 4. That means we need to compress horizontally. So all the x multiplied by 1 over 4 becomes 1/4. We need to compress our graph horizontally. That means from 0 to 2 pi, I'm having the graph like this. So the blue curves. And if I draw a horizontal line, these horizontal line all represent y's value equals 1/2. So this point is 1/2. That means output value, y's value equals 1/2. And then I'm solving for this x. So I need to find the x of this intercept. It's about here. And the x value of this point, x value of this point, x value of this point. So I got 8 solutions because we have 8 intercepts, and these intercepts represent the x value. So we have 8 solutions. And how to solve the 8 solutions? So we need to see there is a table and let you know how to solve the theta, how to solve the x in these equations. So first, we need to isolate the cosine nx or cosine n theta or etc. or tangent to n theta. Second step, solve for the n theta within adjusted solution interval. Multiple each part of original inequality by n. Number 3, multiple the reciprocal of n to the solution you found. What's the meaning of that? So for example, if I have the previous example, I have the sine x and I isolate the sine x. For example, I have square root 2 over 2. And then I know that for one revolution, my sine my x should be in the first and the second interval. And then I can find the x value. But now I changed that. I have a 2x. It's not just the x. What's the meaning of that? That means my 2x equals this angle. For example, this angle is 45 degrees. And this 2x equals from here to here. This is 135 degrees. And then isolate the x, divide by 2 both sides, solve for the x. And also we need to be careful about the interval. That means first we need to solve for the 2x. So we solve the n theta first. And then last step is solve for the theta, because we have the n theta solved. We need to get rid of the n. What should I do? Multiply the 1 over n. So multiply the reciprocal of n. Or you say divided by n. N canceled. I can solve for the theta. Okay, let's move on to see the adjusted interval. So number 2, there is adjusted solution interval. So if, for example, I have a question, I have the sign 2x equals 1 half. So I think, let me see the previous notes. No mistake. So if now I have the sign 2x equals 1 half. And then I want you to solve the x in the interval from 0 degrees to 360. But here, input is 2x. And then at the end, I must have my x in the interval like this. So when I'm solving the 2x first, the 2x is not in this interval. So 2x, so the x, for example, is between 0 and 360 degrees. So the 2x, I need to multiply by 2 everybody on the inequality. So I need to have my 2x greater than 0 and less than equal to 720. So I have the adjusted interval. So first we need to have the adjusted interval first. So if I'm solving the theta between 0 degrees to 360, I need to find the adjusted interval first. That means everybody multiply by n. This is the interval of the n theta. Find the value of n theta first. Then we need to find the x. All right, let's see how to find the adjusted interval, adjusted solution intervals. So if I have the question, I ask you to solve the theta between 0 and 360. Then my equation contains the input angle 2 theta. 2 times theta. That means everybody multiply by 2. Then I have the new interval, which is 2 theta is starting from 0 degrees. And then the bound on the right is 720 degrees. And how about next one? If I have 1/2 theta, that's my input angle, or we say theta over 2. And I want you to find my theta between 0 degrees to 360 degrees. What is adjusted interval? So everybody divided by 2. So I'm getting theta over 2, 0 over 2, 360 over 2. Then the new interval for the theta over 2 is between 0 degrees and 180 degrees. How about next one? If my input angle is 3 theta, I'm looking for my theta between 0 and 360. What is the adjusted interval? So everybody multiply by 3. I'm having 3 times 0 degrees less than or equal to theta. 3 times theta and less than 3 times 360 degrees. So the theta, 3 theta is bounced between 0 degrees to the 1080 degrees. So let's first find the interval of 3 theta, and later we find the angle theta. Let's see the first one. Solve for x. The x is in the equation, and here is another given information. X is, so find the x over 0 to 360. Oh, that means my x must be between 0 degrees to 360 degrees. And now I see my input is 2x. The meaning of 2x means the adjusted interval is 2 times x, 2 times 0, 2 times 360. Then adjusted interval, which is 2x, is between 0 degrees less than 720 degrees. All right, let's isolate the sine 2x first. We need to isolate this part first. First, we need to divide it by -2. So we have sine 2x equals negative square root of 2 over 2. Okay, if I have the sign is negative, which quadrant of my 2x? Because I need to solve the 2x first. So my 2x must be in these two quadrants because my sign is negative. And what is the reference angle here? Because the square root of 2 over 2, that means my reference angle is 45 degrees. So we have 45 here, 45 here. And what is the angle of the 2x? If I just say so from the graph, just to say 1 revolution. So 2x equals, if in the third quadrant, I'm having 180 plus 45 is 225. And I have another solution, 2x equals in the fourth quadrant, I have 360 minus 45 degrees, which is 315 degrees. And are we done? No, look at here. Why we are saying adjusted interval? My 2x is between 0 and 270. That's 2 revolutions. That means from the image, I found the 2 angles in 1 revolution. If in 2 revolution, I need to find the coterminal, another coterminal of 225. Another coterminal of 225. So based on this terminal side, I do another rotation all the way back. What is that? The 225 plus 360, right? So here, number 2, solve for n theta within adjusted solution. So they are not only 225 and 315. The first solution is 225 degrees. Second is 315 degrees. And next one, I can say 225 degrees plus 360, 1 revolution. The coterminal of 225. And next one is 315. 315 degrees plus 360. So another coterminal angle. So coterminal angle of the angle in the fourth quadrant. So I add 360. So the solution should be 225 degrees, 315 degrees. And add them together, I'm having 585 degrees. And we have 675 degrees. And now multiply. So yes, these 4 angles, they are in the interval from 0 to 2x. 0 to 720 degrees. Now, what should I do? These angles, so these angles are 2x equals all of these. I should have 4 equations. So 2x equals 225, and 2x equals 315, and 2x equals 585 degrees. 2x equals 675 degrees. I'm solving for the x. I'm not solving for the 2. I need to get rid of the 2. How to get rid of the 2? Divide it by 2 or multiply by 1/2 both sides. So if I'm using dividing method, divide by 2, everybody. So the x equals 1, so do the division, 112.5 degrees. And then x equals 315 divided by 2 is 157.5 degrees. And then do the division, and x equals 292.5 degrees. So last one, so x equals, so divide by 2, It is 337.5 degrees. You can list them in the set notation. 112.5, 157.5 degrees, 292.5 degrees, and 337.5 degrees. I got 4 solutions. All right, let's see the next one. Solve for the x tangent 3x equals negative square root of 3 over 0 to 2 pi. Find the adjusted interval first. So what is the input angle? 3x. Okay, so I must find my x between 0 and 2 pi. How about 3x? Oh, 3 multiplied by 3. So my 3x is adjusted interval. It's bounced between 0 and 6 pi. Now we are solving the x in the radian mode. So we need to isolate the tangent 3x first. It's already isolated. I don't need to do anything because I'm having tangent 3x equals negative square root of 3 over 3. So next step, I need to find the 3x. I need to find the 3x. The value is between 0 to 6 pi. And tangent 3x equals negative something. So negative angle for the tangent is in which 2 quadrant. So tangent negative in these 2 quadrants because ASTC. So in the second and the fourth. So for example, I randomly draw 2 terminal lines. And this information gives us the reference angle, which is 30 degrees. And now in the radian mode is pi over 6. So here is pi over 6. Here is pi over 6. So my 3x, from the image, I can tell it is pi minus pi over 6. It is 5 pi over 6. And in the fourth quadrant, 3x also equals is 2 pi minus pi over 6 is 11 pi over 6. All right, done? No, this is just 1 revolution. We need to find my 3x between 0 to 6 pi. That's 3 revolutions. What's the meaning of that? So these 2 values are not enough. I need to add the 1 or 2 revolutions, rotations to see the coterminal angle. So first angle is first angle is say 5 pi over 6. Second angle is 11 pi over 6. So based on this one, 5 pi over 6, I can add 1 revolution, 2 pi. And based on the 11 pi over 6, add 1 revolution. Is that enough? I don't know. So how about add another revolution? So that's a 5 pi over 6, add 4 pi. And 11 pi over 6 add 4 pi. I think it's okay because this one is less than 2 pi. So less than 2 pi plus 4 pi is less than 6 pi. That means it is in the interval from 0 to 6 pi. So we have 6 solutions. Let's reduce the form, combine the pi and pi, the like terms. We are having 5 pi over 6. First solution, 11 pi over 6. And next one is, we need to combine them together. 5 plus 12 is 17 pi over 6. And 11 plus 12 is 23 pi over 6. And we have 17 plus 12 is 29 over 6. And last one is what is that? Is 23 plus 20 plus 12 is 35. So 35 pi over 6. Okay, so we got 6 solutions. We're not done because all of these are 3x equals all of these. If I'm solving for the x, what should I do? I need to divide it by 3, all of them. So everybody divided by 3. My new solution is first one divided by 3 is 3 times, is 1 over 3 times 5 pi over 6. So I don't want to do the multiplication. And then I skip the step. I just list the solution here. So 5 pi multiplied by 1/3 is 5 pi over 18, 11 over 18, and 17 pi over 18, 23 pi over 18, 29 pi over 18. Last one is 35 pi over 18. And you must be careful that all of these angles, they are between 0 to 2 pi, because we're solving for the x between 0 to 2 pi. If your solution has the value that's greater than 2 pi or less than 0, you have mistake. Go back to check your solution. All right, let's see next one. Okay, this one is a little bit different. It says solve for this equation for all solutions. It doesn't give us the intervals, for example, the axis between something. We like this kind of question because there is no bound for us. That means I don't need to find the adjusted solution. So say 3 axes bounce between some value to some value, because there's no fence, no bounds for us. So we can add anything I want. But the first step, I still need to solve for the sine 3x first, then solve for the 3x, then solve for the x. Let's isolate the sine 3x first. We need to add 1 both sides. We have square root of 2 sine 3x equals 1, and then divided by square root of 2 both sides. I'm having sine 3x equals 1 over square root of 2. That is square root of 2 over 2. Okay, so the sine 3x equals square root of 2 over 2. Where is my angle? Which quadrant of my angle 3x? So positive sine value, I must have angle in first and the second quadrant. And the reference angle is pi over 2. This one didn't ask you in radian mode or degree mode. Let's say this radian mode, pi over 4. And then the actual value for the 3x, from the image, I can tell the angle is pi over 4, or 3x equals pi minus pi over 4, which is 3 pi over 4. I got 2 solutions. And then we say there's no bound. So if based on the first angle, I do 1 revolution, I got coterminal. 2 revolution coterminal. Or I go backwards some revolutions, I got to the coterminals. So that means based on the first angle, pi over 4, I can plus 2 pi n or 2n pi. So the n is integer. So this is the solution, all solutions for the 3x. So 3x, the general solution is pi over 4 plus 2 pi n. So all the solution for the first angle. And how about second angle? So 3x also equals 3 pi over 4 plus 2 n pi or 2 pi n. N is integer. And here, I don't need to worry about the bounds or fence. We do not have a 3x. It's bounced between 0 and, for example, 6 pi or something. I don't have this. That means I just add 2 n pi, not like the previous when I add 2 pi. And then it's still in the interval, I can add 4 pi. Now there's no bound. That's the reason I added 2 n pi. So several revolutions, and n is integer. Now I need to find my the x. I need to divide it by 3, everybody. Divide by 3. So what is that? If I divide it by 3 or multiply by 1/3. So the x equals pi over, so 1/3 times pi over 4. So that's pi over 12 plus 2 pi n 2 pi n or 2n pi divided by 3. Everybody divided by 3. And another solution is 3 pi over 4 times 1/3. This 3 canceled, plus 2n pi over 3. And if I want to list the solution in the set notation, I say all the x such that x equals pi over 12 plus 2n pi over 3, or x equals pi over 4 plus 2n pi over 3. For all the x is an integer. So if you do not have this, you say x is any integers. Or if you say for short, x is belong to all the integers. All right, let's see. Next example. Next example, oh, we have a fence again. We have a bounds again. You see 0 to 2 pi. That means I can not only plus 2n pi. I'm trying to add 2 pi or add 4 pi. Okay, let's see. How to solve this one? -2 square root of 2 plus sine x over 2 equals -3 sine x over 2. Okay, we have the x over 2. I need to combine all the sine x over 2 together and then move the -2 square root of 2 away. So plus 3 sine x over 2 both sides. We are having -2 square root of 2 plus 4 sine x over 2 equals 0, and then plus 2 square root of 2 both sides. 4 sine x over 2 equals 2 square root of 2, then divided by 4 both sides. I'm having sine x over 2 equals square root of 2 over 2. And where is the angle x divided by 2? In which quadrant? Sine positive, so I'm having my angle in first and the second quadrant. What is the reference angle if I see square root of 2 over 2? Pi over 4. Yes, this is the pi in the radian mode. So my x over 2. Oh, I didn't say adjusted interval at the beginning. I should do that first. It doesn't matter. So x over 2, for example, from the graph is pi over 4. Another angle is x over 2 equals 3 pi over 4. So we should do this first. What is that? Adjusted interval. The previous one is general solution or all solutions. I don't need to have the adjusted interval. But this one, we need to have it. So at the beginning, I know that the given information is x is bounced between 0 and 2 pi. Now I'm solving the x over 2. X over 2, everybody divided by 2. Then I'm having x over 2. So if I'm doing the division, so I have the x over 2 is the bounced between 0 and pi, because 2 pi over 2 is pi. Then I need to find my angle x over 2 bounced between 0 and pi. Are these two angles bounced between 0 to pi? Yes, they are. So I keep these two solutions. And the next part, solve for n without adjusted solution. I solved them because I solved that. X over 2 is pi over 4 because the n is the bottom part. Okay. So another solution, x over 2 equals 3 pi over 4. I cannot add 2 pi. I cannot add 2 pi or add 4 pi because they are too much. It's not in the adjusted interval. And next step, I need to multiply the reciprocal of the n. Now n is 1/2. Reciprocal of 2 is 2. Why I'm doing the multiplication reciprocal? I need to get rid of the 2 here. I need to isolate the x. How to isolate the x? So I can do this 2 times x over 2 equals 2 times pi over 4. Then 2 canceled, x equals pi over 2. And another equation, we use 2 multiplied by x over 2. That's 2 times 3 pi over 4. Do the cancellation, x equals 3 pi over 2. So I got 2 solutions. So they are pi, half pi, and 3 pi over 2. And you see that from the beginning, the axis bounds between 0 to 2 pi. Yes, my solution, the axis bounds between 0 to 2 pi. All right, let's see the next one. Oh, next one, we got to the interval, or we got to the bounds. That means we have the limit. I cannot ignore the adjusted interval. I need to find the adjusted interval first, and then move on to find the general solution. Find the solution. So first step, the question is asking to find the theta between 0 and 360 degree. Now I'm having theta over 2. So theta over 2 is between 0 degree and 180. Okay, let's find the angle between 0 to 180 degree. First, we need to isolate the cosine theta over 2. I can add the cosine theta over 2 both sides. I have 2 cosine theta over 2 equals square root of 2 divided by 2 both sides. Cosine theta over 2 equals square root of 2 over 2. So let's graph it. Where is my angle theta over 2? Cosine is positive in the first and the fourth quadrant. So I may have this one and this one. But let me ask you, my theta over 2 is between 0 and 180 degrees. That means first one and second quadrant. So even I know here make a positive. So here make a positive cosine value, but my angle is not in the fourth quadrant. So I need to ignore the angle in the fourth quadrant, only keep one value in the first quadrant. That means I can only say my theta over 2 equals, the reference angle is pi over 4, it is pi over 4. So that means I have only one solution, which is pi over 4. Okay, so you see, if I have the theta over 2 over 3 over 4 something, my value is getting smaller. We have less solutions. If I have 2 theta, 3 theta, 4 theta, I have more solutions bounds between the given interval. Okay, so I'm looking for the theta. Theta equals what? Theta doesn't have a divided by 2. So multiply by 2 to solve the theta. But I shouldn't have this in this step. I can do it here. So multiply by 2, everybody. So theta equals pi over 2. Oh, half pi is my solution. We're done. And also the half pi is inside the interval 0 to 360 degrees is here. All right.